So ever tried to build a thermoacoustic Stirling engine and been really frustrated by it? Well, that's because up until very recently, thermoacoustic Stirling engines were based on something called the SOS Tube, which is a little bit critical about where you put the stack and where you apply the heat, and if you don't get it just right, it's a pain in the neck to get it to work. Now, that's because an awful lot of research has been done recently on thermoacoustic engines and thermoacoustic tubes, particularly in refrigeration, and it wasn't until the 80s or the 90s this came out when it's called the Huffer Tube. Now the Huffer Tube is a thermoacoustic engine that is non-critical and stunningly easy to make, and I basically have it here. So I've got myself a glass test tube. Now the length actually doesn't matter that much, it's 150 millimeters long, but it really doesn't matter, and there's 4 centimeters of wire wool. This stuff, fine grade wire wool, just rolled up and stuffed in the end there, and you can see it's right at the end. And what I've got here is a bit of 8mm diameter copper pipe with an awful lot of tape around it. The tape is around it just so that I can get that in there. Once I've got that in there, I'm going to tape it up again. And that's to seal everything, so it's all sealed in. And that, believe it or not, is a thermoacoustic engine called a Huffer Tube. Now all we have to do is to get it to run. When it runs, then it will hum. As all of these tubes, when they're working, hum. And then changing it into an engine is a bit different, but not that much, because what we get is a vibration here. And essentially you stick a diaphragm or a piston on this end here, and that vibration is translated into the piston. Now what I've got here is a methylated spirits burner. And I also need my lighter. One of the excruciating things about these tubes is how long they take to heat up. Not so with the Huffer Tube. We just heat up the end there of the stack, which is what that steel wool is. Give it a few moments and we should hear it hum. There we are, humming away. How easy was that? A stunningly easy thing to make, actually, in the basis of a Stirling engine. I wanted to show you the tube. So very often when you try and make these Stirling engines, if you don't try and make the tube first, you wonder where you've gone wrong. So making this tube that resonates is actually the first step to making that engine. So a Huffer Tube, which was used in refrigeration by NASA, is stunningly simple, non-critical, and really easy to make. So it'll hum away all by itself as long as that method is burning. It occurred to me that spirit lamps, actually, certainly for this kind of investigation and for lots of chemistry, are an essential bit of kit, and I've always had a problem finding them, and I don't know why, because they're super easy to make. All you really need is a glass bottle. This is a pill bottle, and this is a clove oil bottle. Once you've got this bottle, we're more or less halfway there. What you essentially do is stuff a wick in there and then some cotton wool and put your spirit in it. I use methanol quite often, actually, or wood spirit. Now, the real issue is this top here. You need to close the top over, and it can be as simple as a washer that fits. You put a washer that fits on it, you got a hole, and your wick comes out of that hole. If you want to go to a bit more to town on it, then these kind of things, this is a plumbing fitting, a compression fitting at 15 millimeters, and it just screws straight on the top there. Now they come with these, which are blanking discs, and you can drop the blanking disc in, screw that on, drill a hole in the centre, you've got yourself a spirit lamp, quite a nice one. Now I want to put a little bit more effort in, and I also want a reasonably large one, so I'm going to use this pill bottle. Now this pill bottle fits quite handily 22mm diameter. So a 22mm diameter compression fitting with the blank end jams right in there. So all I've got to do is jam that in there, and it's quite tight and quite secure, and if you're a bit worried about it, put some PTFE on it, but that's fine actually. I'm going to solder these together because that blank end is just screwed into the compression fitting. So I'm going to solder them together and neaten them up a little bit on the lathe and then drill my central hole. So there's my little brass cap all turned up. Like I say, I could have done the same thing for the smaller bottle with a 15mm and a blanking cap, making it all nice and brass. But it doesn't really matter. You've just got to get something to occlude that, and jamming a washer in, like I say, will do it just fine. Now the wick I'm using is a Zippo lighter wick available from your local shoe store. But you don't have to use that. A bit of string will do actually. The Zippo stays in its one place because it's got copper wire wrapped around it. So a bit of string, some copper wire, it'll do exactly the same thing. Now you don't have to use these. I prefer to use these because in case you spill anything, then obviously it doesn't go everywhere. It's going to be, most of it's going to be held in the cotton wool. You just jam a load of cotton wool in there, keeping your wick free. There we go. And now it's ready to fill up with your spirit. And like I say, I use methylated spirits and just top that right up with meths. I quite like this large one because I do a lot of experimenting and the experiments can last a while. So sometimes if what you're making is a bit small, you can get a bit frustrated by that. And feed your wick through your 4mm hole. There we go. Jam the cap on. Remember this was quite a tight fit. That one's a screw fit. And we're ready to light it. There we are. A little alcohol burner. That will burn probably for about, I think it's about an hour or so actually. The first thermoacoustic engine you see is the singing tube idea. And if you're going back to thermoacoustic engines, you want to have a look at or think about these singing tubes, because the HFF tube was the one that became very popular. It was 1856, a Dutch scientist invented it, and when he would give demonstrations of it, then it would do things like shake the room. And a HFF tube is very simple. It just looks like this. All you really do is apply the heat on that gauze, the air will rise and it creates a standing wave, and we can hear that as a tone. Of course, the problem with HFF tubes is you have to have them upright. Oddly enough though, there was a variant called the Sonderhus tube, which was a horizontal tube. Now a HFF tube is defined by having both ends open. The Sonderhus tube is defined by having one closed end, but the advantage of a Sonderhus tube is you don't have to have it upright, and it will still create a wave that can be used to extract power. So this is a Sonderhus tube. It's a Sonderhus tube because it's got one closed end. Now the stack is right there, and this is 150mm long, so it's 50mm begins the stack. Now in order to get this to work, what we need is a hot end and a cold end. The hot end is easy, we're just going to heat it, but we do need something to keep the other end cool, and the traditional way of doing this is a bit of paper towel. Just wrap a whole load of paper towel around it. Now the stack is 4cm, and I've covered about half of it with paper towel, and I've got some cold water here, so let's just wet that. There it is, singing away. That's actually very cool. Now this is a Sonderhus tube, and it is the basics of all those thermoacoustic Stirling engines that you see. I mean, at the moment we're producing sound, but of course we can produce motion from that. If we put a diaphragm or a piston on this end, it will cause that diaphragm or that piston to move. Okay, so this is the result of lots and lots of work on these resonant tubes, and this wasn't actually invented until the 1980s. It was used in refrigeration. It's called a Huffer Tube, and it's a self-resonant tube. Now the pitch on this is much lower, but it is essentially a larger tube and a smaller tube, and the stack is there, and we heat the stack. Again, needs a few minutes to get going. It's a much deeper note, but you should be able to hear that. Isn't that awesome? Okay, so the length of this tube behind here actually, it's just because I'm using a test tube, it doesn't actually really matter that much, but we have ourselves now a resonance here on the smaller tube, and of course more significantly we're able to heat the end here. We're heating the end of the stack, and in fact this would work if the stack had a tiny gap. So of course heating the end is tremendously significant for what we want to do. It's also very much easier to make a Huffer Tube than it is a SOS Tube. Now, we did a Huffer Tube in the previous video. What I want to do now is make a more robust, but miniature version, looking towards making the big version. And the reason for that is, what do I do if I make a mistake? If I make a huge version and I've never done it before, chances are I'm going to do something wrong. I'm going to have a hell of a job finding it, and I'm going to spend a fortune. So we're going to make a small one. And the small one we're going to make actually is from this plan here. So this is the plan we're going to be using. Now I got that from this research paper. As you can see, the research paper is exactly in the field that we want to be, and this chap has already made this, so we're going to give it a go, reproducing. Okay, so based on that paper, what I did was interpret it a little bit, because obviously I want something chunkier and bigger, so I knocked this up. All it is a couple of bits of pipe that have been separated, and then in between them we've got a glass tube filled with wire wool. That glass tube I just got from cutting a test tube in half, stuffing it with wire wool, and then I put it in the middle of the pipe like that. Now I've stuck this on, which is our heat exchanger. It's the cool end. Now if you remember, that thermal barrier there is a key component. And so we made this. This is our thermal barrier. Now I have seen this made in different ways. A Blader Tiller actually made it out of a Coke can bottom and a pipe fitting, and I made this one from a CPU cooler and some 22mm pipe fitting. So to make this, I have this, which is an aluminium cooling fin from a CPU. It's nice and circular, and Luke gave it to me. I'm going to drill it out so that I can fit a couple of these in there and put the gauze on there. So let's drill it out. Okay, so that's it drilled out. Now then we need a bit of copper in there, and for that I've got 22mm end caps because they fit nicely in there, and we'll be able to solder those in to make it gas tight. So, get another one. We'll drill a lot of little holes in here because we need a kind of barrier mesh. So a lot of little holes in here, then solder another one on top into there, and then aluminium solder that whole thing together. This in here, what we're going to do is flow some solder over it. Now it won't bond to the aluminium, but it will flow over the copper surface and create a nice tight bond by doing that. And that's what we're going to do, because we need good contact to get this to work efficiently. I mean, we could use thermal paste, I guess, but the problem with this is a cooler. So if I turn the blowtorch on this, it's going to take ages to heat up. So what I do with it, and I do the same thing with the solder joints when I do aluminium soldering, is put it on a heated bed so that this whole thing can get some heat in it. Then we can drop our copper in. When it's hot enough, we can flow some solder over the copper, and that should give us a nice tight bond in there and hold that thing in place. Let me give you a close-up of it. So there you go. That's how the whole thing looks once it's finished. It should help improve the performance, but I don't think it's strictly necessary. So once it's like that, you really have to seal it. If you don't seal those joints, it won't work. To seal it, you'll see there's a big lump of brownish looking stuff, and that's this silicate, not silicon, silicate sealant that I got from my local big box store, actually B&Q. It's good to 1200 degrees, it's a silicate putty, and you find it on the shelves. So let's start this thing up, and here's my alcohol burner. Now it shouldn't matter where on there because the whole pipe gets actually pretty hot. There it is singing away. Now I'm going to move the microphone closer so you can hear it, because other people said on the previous video they had difficulty hearing it. So let's reposition the camera and you get a better sound because the microphone will be closer. So to turn this into an engine, what we really need is a piston or a diaphragm. diaphragm moves a magnet through an electric coil, of course you're going to get generation. And to show you that, what I've got here is a small speaker, and that is just a diaphragm with a coil on it moving through a magnetic field. And of course we're recording it. If you ever watch at the meter, there you go. Generating with the Huffer Tube. I'm loving these Huffer Tubes here, the very simplicity of them. I mean, this, you can see that, this is both disappointing and interesting. I've taken that out and it doesn't seem to make much of a difference. So we went through all that trouble of making that, now we're not going to use it. But hey, such is experimentation. But the Huffer Tube turns out to be a little more than a pipe chopped in a third, then a regenerator in an insulator, a ceramic. I'm using glass here with steel wool in it. You can hear that thing. Now the frequency is clearly to do with the length of the pipe. The shorter the pipe, the higher the frequency. There's something really interesting happened actually. So I'll just put that on record because we'll do a pip on this. If you remember on the other one, we got a couple of milliamps out. Now we're getting 4 and 5, millivolts. So there you go, 5.2 millivolts. I mean, it's not knock your socks off stuff at this stage, of course not. But the higher the frequency, the more the generation. That's probably because the coil is being forced to move faster through the magnetic field. Probably has some relationship with amps as well, but we're getting a higher voltage the shorter the tube gets. Now of course we want a short tube because we want to fit it onto that rocket stove. We don't want 3-foot of tube sticking out at the end of the rocket stove. What would be great is a really short tube, and it seems that a short tube is going to work really quite well. I'm not sure if you're picking this up, but that is humming away. It's fantastic. And you can tell it's humming because it's generating, so it is vibrating. So a shorter tube would be great. Now obviously there's a fair bit still to do with it. I want to see how short that tube is going to get. Now when you put a diaphragm on one of these things, what you do is you create a virtual tube, and I don't know yet how long that virtual tube is going to be, which is why I'm using a speaker. If I put a speaker in it, we're using the vibration of the air as it comes out to hit the speaker. What would be better obviously is we were vibrating a diaphragm or moving a piston, and for that what I want to do is find out what length of tube I'm actually going to be using, what the relationships are. Then we'll need to experiment with the diaphragm to find out what that length of that virtual tube is going to be. Now I'm using 4 centimeters here of wire wool as the regenerator. In the research paper that we looked at, they used 7 millimeters of reticulated carbon, so obviously the regenerator is also something that's going to need to be looked at. So it's not going to be a sort of, hey look, it's done tomorrow, but it is certainly an interesting investigation. I love the idea of using these as engines because there's just no moving parts. It's super simple to make, never going to wear out really. This part is never going to wear out. And we'll be able to put some kind of energy collection system at this side here so we get something out. The Huffer Tube, about it, what we want really is something that we can heat just at the end, because we're going to stick it on this, the rocket stove, and this is the bit that gets hot, and all our heat coming from there. We want as little of a tube as possible, and then we want a sounding tube sticking out the back that we can draw the energy off. So we're after a specific thing, and I've been working towards that. Eventually what I came up with was this. So we've been through lots of variations, you by no means haven't seen them all. This is a ceramic floor tile, obviously a mosaic tile, and I drilled a 14mm hole in there and put some wire wool in, with the wire wool going in one direction. Then I've got a cap end which is 15mm, and then a bit of 67mm copper tube. So the whole thing looks like that, and I glued it around with this stuff. And this stuff takes ages to dry, so I've been waiting for that to dry, and here is the result right here. There's my mini Huffer Tube. Now we apply the heat just at the end there, which is exactly what we want obviously. This is the regenerator, and the tile is a thermal break. It's a ceramic thermal break, and then we have the sounding tube there. And to be honest, it's awesome. I don't think you're going to need a close up on this one because it does get a little painful. How about that? Okay, that's enough of that. So we have the tube design we actually want. We're applying the heat just at one end. Sounds beautifully, and of course what we want to do now is put the engine bit on it, but we've got the design that we wanted, so I want to share that with you really, and it's just really stunningly simple. Bit of tile with a hole in it and some wire wool, 15mm end cap, 67mm bit of pipe either side, and then glued on. The important thing is to get that seal right. It has to seal on there. Once it's sealed on there, those dimensions are going to work. Anyway, I thought I would share that with you and let you know that I work on lots of different things all at the same time, because you do a bit and then you're waiting for days for it to actually dry or cure or do something, which is why there's so many bits. Anyway, I hope you enjoyed the update. We are one step closer to actually putting it onto the rocket stove. Thank you very much for watching, and please do remember to like and subscribe.